So example 2. Um, Not everything is always going to work out to a nice integer value. Most of the time, in terms of being an algebra 1, it will, but not everything always will. So that's this is going to be an example of something we call an irrational root. And an irrational root means that when you have that radical, it's not going to simplify down at all. It would behoove you to identify the A, B, and C for every problem on this page before you get started. Our A, B, and C are going to be A is equal to 30. We can see that it's not going to be necessarily nice because if you try to factor this, you're not going to be able to factor it. But this is how you solve problems where you're not able to factor them. Ooh, the bounty hunter. Okay, so let's see. We have our quadratic formula again, which is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's just go through again and follow what we did before, which is setting up our positive case and our negative case. Alright, so the positive case would be negative, well b is negative 12, so that would actually turn a negative negative is a positive 12 plus the square root of b squared, so that's negative 12 squared minus 4 times a is 1 times c, which is 30, and I want to divide that whole thing by 2a. So the first thing we have to do is simplify what's under the radical first. So we have 12 plus the square root of 12 squared, or negative 12 squared. Since the negative is in the parentheses, it's going to become 144 minus 4 times 1 is 4, and then times 30, which should have had a closed parentheses behind it, times 30 is going to be 120. And that's all going to be, of course, over, I don't know why I made 2a like this. I know somebody's going to point it out to me before they recognize that I saw it, but that should be 2 times 1, which is, of course, just 2. And I'm not going to make the same mistake as last time. I'm going to give myself some more white space down here. Learn from your mistakes, people. That's what I always say. Or actually, I have never said before. Goodbye. Okay. So this is going to be 12. Let me switch back to black. 12 plus the square root of 144 minus 20 is going to be 20. I don't know why I was going to write 14. It's not. It's 24. plus the square root of 24 over 2. And the square root of 24, of course, is going to break down into, so we have now 12 plus square root of 24. That can break down into, let's do it on the side here. I'm going to put a little box to show it has nothing to do with the problem. But that's radical 24, perfect squares that go into 24. I know 4 goes into 24, so I can do, let's say that would be the square root of 4 times the square root of 6. Square root of 4 is 2, so that could be 2 radical 6. And then that whole thing is over 2. The only thing that is not fun about, oh no, you can see that stuff I tried to hide from you. That is so embarrassing. The only thing that's sort of a pain in the butt about this method, actually, this case isn't so bad because really you don't have to do much more work after this. The only thing you need to do is separate these fractions and simplify. So this actually has to become 12 divided by 2 is 6, right? So, and then 2 radical 2 divided by 2 is plus the square root of 6. The 2's will cancel out. So you just have to make sure everything is completely simplified. So that's our answer. It's an irrational root. And when we do the negative side, the negative case, everything else is going to work out exactly the same way. Everything inside the radical is going to work out the same way, but the only difference is that we're going to have a minus instead of the plus. So the answer for the negative side is actually going to be 6 minus the square root of 6. So you might see it like this, see your answer is written as both of these, but the other way you'll see the answer is still 6 plus or minus radical 6. And you can evaluate these functions in your calculator. It'll work out to be 0. Like if you graph this in your calculator and then go to the table and actually punch in 6 minus the square root of 6, the 0 will come up. If you put in 6 plus the square root of 6, the 0 will come up. Unless, of course, that is I made a mistake, and that would be terribly, terribly, terribly embarrassing. So go ahead and try the rest of the problems. This side should be a little bit more complicated, so the answers will be up on Blackboard, but if you need any help, you just stop me and ask me.